All right, now we're going to talk about mean, variance, and standard deviation. This is standard level IB, chapter 7, um, lesson L. So you may already know this, but mean is the average of data, okay? And in statistics, they describe the mean with this variable here, which is called mu. It's a Greek U, okay? And you can calculate the mean by having the sample space number times probability, okay? So sample space is the number of times you're going to do something, and it's the probability. So now variance is a measurement of how far the data varies from the mean. So just hold that thought and just think about this. So we'll be using this curve more when we start talking about normal distribution, but this is just to represent what standard deviation is. So first of all, the larger the spread of the data, the larger the variance is. So let's just say I'm going to roll a die, and I roll it, 10 times versus rolling a die like 1,000 times. You're going to expect to get, if I roll it 10 times, the average of, let's just say I roll it 12 times. You know that I'm about to get it, you would get a number 6 like twice, right? And let me continue. So variance is expressed with the number, the sample space, times the probability of getting something, and then times this is like 100% minus that probability. Okay, so standard deviation is a measure of how far the spread of the numbers are from the result here. So standard deviation is represented by the symbol mu. Okay, so and standard deviation is represented by the square root of the variance. Now let's do an example. It'll help make more sense. Okay, so if I'm a fair die, if I'm rolling a die, it's got 1, 2, 3, 4, 5, 6, right? And if I roll it 12 times, and we want to know how many times are we going to get the number 6. So we're going to use x for our distribution, and we want to find the mean and the standard deviation. Okay, so if I'm rolling it 12 times, that means n is going to be 12, and the probability of getting a 6th is 1/6, right? Because 1, 2, 3, 4, 5 are the other numbers, and we have a 1/6 chance of getting a particular number. Okay, so often you'll see in this type of mathematics, you're going to see it written like this. So for our binomial distribution, they write a b, and this is our sample space, and this is our probability. Okay, so if I want to find the mean, well, if I multiply 12 times the probability, we get a 2. This means we expect if we roll a die 12 times that we're going to get the number 6 twice. Okay, well now let's figure out the variance. Using this formula to find the variance, 12 times 1/6 times 5/6, you end up with 1.66. Repeating. And if I take the square root of that, I'm going to get 1.29. So what does this value mean, the standard deviation value mean? So hopefully this will help make more sense. Okay, so if I roll a die, we know that we expect that we're going to get a 6 twice. But sometimes we're going to get a number 6 3 times. Sometimes we're going to get a number 6 only once, right? That's what happens when you roll a die, right? But standard deviation wants to know 68% of the time, what are you going to get? So if I add 1.29 to 2, that means we get 3.29, and if I subtract 1.29, we get a number smaller than 1. So, but you're not going to get a fraction of a number 6, right? You're going to get a whole number 6. So let's look at it with a larger sample space. Okay, so the smaller the sample space, the smaller the standard deviation. We had a standard deviation of 1.29. So what if I roll the die 100 times? Okay, so now we can write it like this. Our sample space is 100, and the probability is still 1/6, right? So to find the mean, we're going to multiply 100 times 1/6, and we get 16.6. Okay, that means we expect to roll a 6 about 16.6 times. Okay, now our variance is equal to, using this formula, we do 100 times our probability times 1 minus that probability, and we get 13.8. Now, standard deviation is the square root of that, so the square root of 13.8 is 3.7. So if I look at the curve, in order to get 68% of the time, I add 3.7 to 16.6 and we get 20.4. I subtract 3.7 from 16.6 and I get 2.8. So that means if I roll the die 100% of the time, 100 times, we expect that we're going to get the number 16.6 times. But if I go one standard deviation higher, we would roll the number 6 20.4 times. If I go one standard deviation lower, I expect to roll the number 6 12.8 times. So 68% of the time, I'm going to roll a number 6 between 12.8 times and 20.4 times. I know this is a little bit tricky. You may want to watch this video a few times. And definitely ask for help during office hours if this is a little tricky.